Hello everyone. In this video, we will learn to identify a redox reaction and to determine the oxidizing and reducing agents in a given redox reaction. In the earlier video, we learned all the rules to assign the oxidation number of each atom on a given compound. Now let us use these oxidation numbers to identify if a given reaction is a redox reaction or not. This is the example redox reaction that we discussed in the earlier video. Solid magnesium reacts with gaseous chlorine to form solid magnesium chloride. Let us assign the oxidation numbers for each atom before and after the reaction. On the reactant side, magnesium is in its elemental form. Therefore, its oxidation number is equals to 0. Similarly, chlorine is also in its elemental form, that is Cl2 gas. Therefore, the oxidation number of each chlorine atom is also equal to 0. Now let us look at the products. Magnesium is now in a compound and it is a group 2 element. Therefore, its oxidation number is +2. Chlorine belongs to group 7. Therefore, its oxidation number is -1. And if we add up the oxidation numbers of all the atoms in magnesium chloride, it should add up to 0, which is the charge, the overall charge on magnesium chloride. Let us now highlight a few important characteristics of a redox reaction. The oxidation number of magnesium increases from 0 to +2. That is, magnesium atom loses 2 electrons in this reaction. The oxidation number of chlorine decreases from 0 to -1 in this reaction. That is, each chlorine atom gains 1 electron in the reaction. Now let us define the terms oxidation and reduction. The term oxidation is an increase in the oxidation number or loss of electrons. And the term reduction is decrease in the oxidation number or gain of electrons. You can use the following mnemonic to remember this. Oil rig, which stands for oxidation is loss and reduction is gain. Now, if we look at this reaction, we can say that magnesium is being oxidized and chlorine is reduced. These two reactions, that is oxidation and reduction, always occur together. That is, no one reaction can occur without the other. In other words, if one species is losing electrons, there should be another species which accepts those electrons. In the above reaction, magnesium is being oxidized and chlorine is helping magnesium undergo the oxidation process. Therefore, chlorine is called as oxidizing agent or oxidant. Similarly, chlorine is being reduced and magnesium is helping chlorine undergo reduction. Therefore, magnesium is called as reducing agent or reductant. A reducing agent always undergoes oxidation in the reaction and the oxidizing agent always undergoes reduction in the reaction. Now let us do some more examples on how to identify a redox reaction. Let us do an example. Which of the following reactions are redox reactions? And for each redox reaction, identify the oxidizing agent and reducing agent. To answer this question, first we need to assign the oxidation numbers for all the atoms in each of the reactions. Next, we check if any of the atom's oxidation number is changing in a reaction. If it does, then it is a redox reaction. If oxidation numbers remain constant before and after the reaction, then it is not a redox reaction. Let us assign the oxidation numbers for reaction 1. On the reactant side, magnesium is in its elemental form. Therefore, its oxidation number is 0. Next, sulfuric acid. Hydrogens are in combination with sulfur and oxygen. Both of them are nonmetals. Therefore, hydrogen has an oxidation number of +1. And oxygen in combination with nonmetal usually has an oxidation number of -2 unless if it is with fluorine or if it is a peroxide. We can calculate the oxidation number of sulfur using the formula 2 times the oxidation number of hydrogen plus 1 times the oxidation number of sulfur plus 4 times the oxidation number of oxygen is equals to 0. If we solve for it, we get oxidation number of sulfur as +6. Let us now move to the products. Magnesium is in the form of a compound and it is a group 2 element. Therefore, its oxidation number is +2. The oxidation number of oxygen will be -2, and we can calculate the oxidation number of sulfur using the same formula, and we get it as +6. Next, hydrogen. Hydrogen is in its elemental form. Therefore, the oxidation number of each hydrogen is 0. Now, take a look at this reaction with all the oxidation numbers listed and check if there is any atom whose oxidation number is increasing in the reaction. As you can see, the oxidation number of magnesium is increasing from 0 to +2. Therefore, this is an oxidation reaction. Now, we learned earlier that an oxidation reaction and a reduction reaction always occur together. That means there should be some other species which is undergoing reduction or whose oxidation number is decreasing. Let us now identify that. The oxidation number of hydrogen is decreasing from +1 to 0. Therefore, we can say that it is undergoing reduction. So, this reaction is definitely a redox reaction. Now let us answer the second part of the question. That is, we need to identify the oxidizing agent and reducing agent. We learned in the earlier video that oxidizing agent undergoes reduction in the reaction and reducing agent undergoes oxidation in the reaction. Therefore, we can say that magnesium is a reducing agent because it is undergoing oxidation, and hydrogen in sulfuric acid is a oxidizing agent because it is undergoing reduction. Now, pause the video here and try to answer the remaining two questions. Let me first assign the oxidation numbers for reaction number 2. Hydrogen is +1. Oxygen will be -2. Therefore, the chlorine will be +7. Sodium +1. Oxygen -2 and hydrogen is +1. Sodium is +1, oxygen -2, and chlorine will be +7. In water, hydrogens will be +1 and oxygens will be -2. As we can see, the oxidation numbers of all the atoms remain constant during the reaction. Therefore, this is not a redox reaction. In fact, this is an acid-base reaction, that is the reaction between perchloric acid and sodium hydroxide. Let us now assign the oxidation numbers for reaction 3. Oxygen in combination with metals has an oxidation number of -2. Therefore, manganese is in +4 oxidation number. Aluminum is in its elemental form, therefore its oxidation number is 0. Let us now look at the products. Manganese is in its elemental form, therefore its oxidation number is 0. In aluminum oxide, oxygen is -2 and aluminum is +3. So the oxidation number of manganese is decreasing from +4 to 0, that is, it is undergoing reduction. And the oxidation number of aluminum is increasing from 0 to +3, that is, it is undergoing oxidation. So this is a redox reaction, and the species that is undergoing oxidation, which is aluminum, is a reducing agent, and MnO2 is an oxidizing agent. If a reaction has an element in its pure elemental form on one side and in the compound form on the other side, that means its oxidation number is definitely changing. Therefore, it is definitely a redox reaction. This is a quick way to see if the reaction is a redox reaction or not. As you can see, in reaction 3, on the reactant side, aluminum is in its pure elemental form, and on the product side, it is in a compound. Therefore, it's a redox reaction. If we look at reaction 1, magnesium is in its elemental form on the reactant side and in a compound on the other side. Therefore, it's a redox reaction.